Hello students, sorry for the late, but today I'm going to start with the Venn diagram. So in this, I'm going to tell you that what is Venn diagram and some of the sets operation on sets. So for this, firstly see this. This Venn diagram is nothing but the geographical representation of the set to give you a perception and idea how it is. So firstly, you have already read about the universal set. So it is represented it is represented with a rectangle, and we represent it with u, and their subset, if we have defined any universal set, and then if there is any set, so which these sets are represented with the circles in the Venn diagram, and let's say this is set A, this is set B. Okay, so by this way we represent the Venn diagram. Let's see some of the operations, and then we will understand this Venn diagram very clearly. So the first operation is operation on sets. Operations on sets. So the first operation is union of sets. So it means if there is any two sets, set A and set B, then the union of set A union B, it will be represented with A union B with the sign of U, and we read it A union B. So it will consist all the element of A and B completely. Okay, it will not left any element of A or B. Okay, so it is defined as, like, if I am saying that A equals to 1 2 3 and B equals to 3 4 5, so then A union B will be 1 2 3 4 5. Okay, so it is consisting all the elements of A and B also. Okay, so the mathematical definition of this A union B is X such that X belongs to A or X belongs to B. For every element, if I am taking any element from A union B, it should belong to either A or B. Okay, and the understanding with, let us understand this with Venn diagram. So let's say this is a universal set. So set A is like this way. Okay, and set B is like this way. Set A, set B. Why I overlap, you will see in the just next situation. I will tell you that why I overlap here the circles and not in this in this figure. Okay, so the A union B represents the all the element of A and B together. So there is no element left from A and B. Okay, so all this area, not outside A or B. Okay, so again see the I will take this example for further situations also, so keep in mind A and B. So the second one is the intersection of sets. Okay, so this intersection of sets is like we have defined A equals to 1 2 3, B equals to 3 4 5. So it means if there is set any set A and B, so intersection of A and B will be represented with by this, and it will consist that element which are present in both A and B. So by seeing this A and B, we can say that only the element 3 is common in between them. Okay, So let us understand with this with the Venn diagram. So this is an universal set. This is a set. This is another set B. This is, let's say, this is set A and this is set B. So the intersection represents this area only, which is overlapping. If there is something common, we will show it with overlapping figure. If there is nothing common, so we have to represent it with separated circle. So now hope you got the idea what is A intersection B. So now this is written as A intersection B is written as x such that x belongs to A and x belongs to B. It means जो x इसमें लिया गया है वो दोनों में belong करना चाहिए. Okay, so based on this intersection of sets, we have another definition: disjoint sets. Disjoint sets. Okay, disjoint sets. What it means? If there are two sets A and C, I am not taking B because A intersection B has an element, common element. Okay, and I am taking this C as 7, 8, 9, and again A is similar 1, 2, 3. Okay, so disjoint sets will be called those two sets, those pair of sets which are having no common in between them. So in this situation, A intersection C is phi. Okay, not phi. It will be not written like this. It will be written like this way or phi. Okay, if I am writing phi here, it means it is representing an element in this set. So whenever the intersection will be phi, these two sets will be called disjoint sets, and this meaning is also representing the same. Disjoints means they which are not joint by any means. Okay, so in this situation we have to show the Venn diagram with separated circle. A and C. So if this is representing A, this is representing A, this is representing C, and again if I want to represent B also, then again B and C has no common things, so B will be like this, but it will be also separated with C. Now hope you got it. Okay, and this region is again representing the A intersection B. Okay, so next we come up on the complement set. Complement of sets. Complement of sets. It means like it is if there is any set A, so A dash will be representing the complement of sets. So if there is some sets A, B, C, and for that there is universal set is defined. Let's say universal set is defining like 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so then A dash will be all the element except A. A dash will be consisting all the element except A. And now by this means except A means all the element of universal set except A. We don't want any element of A. By this way A dash will be 4, 5, 6, 7, 8, 9, 10. Again this B dash will be 1, 2, 6, 7, 8, 9, 10. C dash will be 1, 2, 3, 4, 5, 6, 10. Okay, Hope you got it. And then let's say I can say that okay, so how it represented on Venn diagram. So it will be like this way. It will be represented like this way. This is universal set U, this is set A. So all the region except A, so this area is representing the complement of A, all this region except A. Okay, so now let's say in this situation again, if I am saying that intersection of dash of this, so all the region except all the area except this region will be representing this. Again, if I am saying that A union B whole dash, then it will be representing that all the region, all the area except this yellow color. So this region will be representing this A union B whole dash. Okay, are you getting my point? So whenever we are doing this, there is something called like we can see the formula for this. A dash means U minus A. Okay, so again if I am saying that A union B whole dash, so it will be U minus A union B. Okay, before that we need to understand the what is this minus represents. So let's understand the difference of sets. Then we will come back to it. So fourth one is difference of sets. If there are two sets A and B, so A minus B will be containing that element. A minus B will be containing that element, like it will consist all the element of A except that element which are also present in B. Okay, so early, like it is A 1 2 3 and this is 3 4 5. I think let me confirm from the above given data. Yes, it is 3 4 5. So by this way I am saying that all the elements of A except B which is also present in B. So we can take 1, we can take 2, but we can't take 3 because it is also present in 3. This means B minus A minus B. So what is the meaning of B minus A? It will also be the same, all the element of B except that element which are also present in A. Okay, so it will be 4 comma 5 only. Okay, so if we write the mathematical definition of this, so it will be X such that X belongs to A but and doesn't belongs to B. Hope you got it. Okay, so let us understand the Venn diagram for this. So Venn diagram will be like this way. This is A, this is B. Okay, this is A and this is B. A, B. So I am saying that A minus B. So all the elements of A except B which is also present in B. So this is the region which represents the A minus B. Okay, and what is the B minus A? So this B minus A is this region. Okay, B minus A. Okay, hope you got it. So let's come back to the previous one. Now you will be understanding what it means U minus A. So we are excluding all that element which is also present in the set A, which represents the A dash. Okay, hope you got it. From this I would like to tell you one more thing, like what if I am doing A dash of dash, so it is U minus of A dash. And what is A dash? U minus of A. Okay, which is also, let me write, I think this is not visible, so let me do it something here. Okay, so now this is okay. Now you will be seeing that, so U minus U, it will be U minus U plus A, so you will be cancel out each other. Like if I am subtracting all the element of U from U, so we will get nothing, it will be 5. And adding means the summation, it means the union, and minus means we are removing that element. Okay, so we are getting A, so A dash of dash means A. Okay, and hope you got it, the meaning of the disjoint set also, and now the difference of sets. And the last thing which is I am going to tell you, the fifth one, symmetric difference of sets. Symmetric difference of sets. If there is two sets A and B, it will be represented by this way, A triangle B. It means A minus B union B minus A. A union B minus A minus B union B minus A. What it means, if I am saying that A is 1, 2, 3, B is 3, 4, 5, so it will be A minus B will be 1 and 2 union 4, 5 B minus A, and it will be 1, 2, 4, 5. We can also see that this is the union of this A minus B and B minus A. So we can say that it is also representing the same thing, A union B minus A intersection B. Is it right? Are you able to see that? What the A union B means? A union B means the whole area, which is also present in A and B also together. Okay, this whole area, and we want to remove which area which is common to both. So this region we want to remove, so what we will get again in the similar situation what we were doing here. Okay, so for today's lecture I am concluding it here, and we will see it in the next class. Okay, bye.